If I look at the next one, circle that answer. The next one's a little bit tricky because now I have two exponential parts of this function, and I can't isolate them. I mean, they're both isolated individually, but I can't use one or the other. You could do log base 5 of each side or log base 8 of each side, but it causes a mess here. So what I'm going to do is I'm just going to take the natural log of each side. So I'm going to take the natural log of this side and the natural log of this side. Let me rewrite that so it's a little bit clearer. I've got 5x plus 2, 8 to the, give myself some space here, 8 to the 2x, and I'm going to take the natural log of each side. Okay, so I'm going to go right to the natural log because it doesn't benefit me that much to take log base 5 or log base 8. Okay, so now here I can bring the exponent out front, so that's x plus 2, natural log of 5. Over here, again, I can bring the exponent out front, the 2x natural log of 8. And I could have only brought part of that down, but we'll discuss that a little bit later here. So now I'm going to simplify a little bit. I'm going to bring this guy and distribute it. So that's going to be an x plus 2 natural log, x natural log of 5. Almost completely forgot my natural log of 5. Plus 2 natural log of 5 equals 2x natural log of 8. And before I start moving a bunch of stuff around, I'm going to simplify this a little bit using my properties of logarithms. This 2 I can rewrite as an exponent. This 2 I can also rewrite as an exponent. So that's going to be an x natural log of 5 plus the natural log of 5 to the second, which is 25, equals x natural log of 8 to the second, which is 64. Now I have to get my x values together, so I'm going to subtract the x natural log of 5 from each side. And when I do that, I'm bringing it up here, I'm going to have the natural log of 25 equals x natural log of 64 minus x natural log of 5. And now from here to isolate that x value, I got to factor it out. So I'm going to have the natural log of 25 equals x natural log of 64 minus the natural log of 5. So I factor the x out. And now to make this even simpler, I've got two logarithms of the same base being subtracted inside the parentheses here. I can rewrite that as one logarithm of the two things being divided. So that's going to be, let me, so I don't run into my old problem here. So that's going to be the natural log of 25 equals x. This I can just rewrite as the natural log of 64 divided by 5, which I believe is a 12.8. Okay, and what that does, it just makes it a lot simpler for me to plug into my calculator. All right, so now here I'm going to divide each side by the natural log of 12.8. So I'm going to find out that x equals, and I'll just have to plug this into my calculator, the natural log of 25 divided by the natural log of 12.8. So it turns out that x is going to equal 1.2626. Okay, again, to 4 decimal places. All right, so that's what we get when we plug this into the calculator. Okay? Again, much more involved when you have two exponential pieces. If I look at this next one, this is one of our examples of exponential growth. We've got an investment of $1,000 is earning 8% APR. That's annual percentage rate, but it's compounded quarterly. Okay, so keep that in mind because we're going to have to do something with that for our units to match. And we want to find the number of years needed for the investment to double. All right. Since this is happening quarterly and it's not happening continuously, it means I'm going to use my standard model for growth, which is the y equals a times 1 plus r raised to the t. Okay? My initial amount is easy. That's the 1,000. Okay? That's how much I'm investing. All right? The 8% APR is where it gets a little bit tricky. See, that's a yearly percentage. That's 8% per year. So that's like 0.08 per year. But I'm compounding it quarterly, so I have to change that to a percent per quarter. So that means I have to divide this value by 4. All right, so I divide that by 4. That's going to give me a 0.02, and that's per quarter, which is good because I need my units to match. If it's being compounded per quarter, my percent has to be per quarter. My time is going to be in quarters. All right, and now time is the thing I'm looking for. It asks me, how long will it take? and it wants to know how long for this investment to double. So if I want this to double, that means I want to end up with $2,000. All right. I started with 1,000. I want to end with 2,000. And now I just have to solve this for t. So I'm going to simplify a little bit. So I've got 2,000 equals the 1,000. And this is going to be 1.02 raised to the t. And now I'm going to isolate the exponential part of the function. So I'm going to divide each side by the 1,000. So that's going to give me 2 equals 1.02 raised to the t. And now to solve this, I have to use logarithms. So I need to use a logarithm of each side. And for this one, you could use the natural log. I'm going to use log base 1.02. All right, I choose the base of the exponential function because it just makes it a little bit easier, makes things cancel a little bit nicer. So log base 1.02 of each side. Over here, the log base 1.02 and the 1.02 raised to a power cancel out. So I'm just left with t. Over here, I just have to use my change of base formula. Natural log of 2 over to the natural log of 1.02. And when I do that, I'm going to find out that x equals, let's take it to my calculator here again. Half of these problems just being able to make sure we can plug it into the calculator correctly. Natural log of 2 divided by, again, make sure you close off those parentheses, natural log of 1.02. So it looks like 35.002788878. And notice I'm ignoring the directions here. The directions said, hey, round this to 2 decimal places, but it also asked for this to be in years. And this is the number of quarters. Okay? So what I have to do is I have to take this final answer before I bother rounding it off. I've got to divide it by 4. Okay? Because it's 35 quarters. Well, there's 4 quarters in each year. So if I want to know how many years it is, divided by 4, I find out that t equals 8.75 years. Okay? Now everything is in the correct units. Again, I had to change that to per quarter because it's compounded quarterly. But then when I get my time, it's in quarters. I've got to change it back to years because that's what the question asked for. Okay? So 8.75 years. Alrighty?